Okay, so today we're going to learn a few more identities that we can use. And the really cool thing is that all of the stuff we're learning today, you guys will have on the test. So none of the identities from today, you don't need to have any of them memorized, which is great. So there's a difference identity for the cosine function, and there's a sum identity for the cosine function. And these are what they are. Now these are great because they're actually going to help us figure out identity or the exact values without using a calculator of angles that are not our special angles. So for example, if we were having to find the cosine of 75, normally we wouldn't be able to do that. When you look at your cheat sheet, or not your cheat, but your little table, we've got this sine, cosine, tangent, and then we learn about 0, the 30 degrees or pi over 6, 45 degrees or pi over 4, 60 degrees or pi over 3, and then 90 degrees or pi over 2. So when we have all those, we've learned what those things are. So we've got 0, 1/2, root 2 over 2, root 3 over 2, 1, 1, root 3 over 2, root 2 over 2, 1/2, and 0. And then I'm going to leave the tangent out for right now because we don't need it. But so if we're trying to figure out the exact value of the cosine of 75 degrees, so I can use one of these identities to do it. So figure out two angles that are special angles that we know that either add up to 75 or subtract to 75. So when I look at this, I see easily that I could rewrite this as the cosine of 30 degrees plus 45 degrees. We have 30 and 45 are two of our special angles, and 30 plus 45 is 75. So once I have it written like this, then all I have to do is plug everything into these formulas. So that's going to give me the cosine of 30 times the cosine of 45 plus the sine, or excuse me, not plus, I always mess that part up, which is a good thing that you guys don't have to memorize these, minus, so it's the opposite of what you would think it would be, the sine of 30 times the sine of 45. So that ends up giving me, all right, well, the cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. The sine of 30 is 1/2. Sine of 45 is root 2 over 2. So this gives me square root of 6 over 4 minus the square root of 2 over 4. So that leaves me just with the square root of 6 minus the square root of 2 all over 4. That can't simplify any further because those are stuck in there. So what's cool is this identity actually helps us figure out values that we never could really find before. All right, so let's do some more examples of this. So if we had to find the exact value of the cosine of pi over 12, well, I don't know what that is in my head. So we need to see if we can find a way to write this as the difference or the sum of two angles that we do know. So the angles we know from that handy dandy chart are 0, pi over 6, pi over 4, pi over 3, and pi over 2. So what I'm going to do is I'm going to convert those so that those are all in terms of a denominator of 12. So pi over 6 is equal to 2 pi over 12. I just multiplied 2 over 2. Pi over 4 is equivalent to 3 pi over 12. Pi over 3 is equivalent to 4 pi over 12. And then pi over 2 is equivalent to 6 pi over 12. So I can see right here that I can totally rewrite this. This is the same thing basically as I can write it as 3 pi over 12 minus 2 pi over 12. Or I could have done 4 pi minus 2 pi, or 3 pi. So that's equal to cosine of pi over 4 minus pi over 6. And we have values for all of these, which is great. So that gives us, using the difference formula down here, that's going to be the cosine of pi over 4 times the cosine of pi over 6 plus the sine of pi over 4 times the sine of pi over 6. So that gives us root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1/2. So I get, again, root 6 plus root 2 all over 4. All right, next one. So when I look at this, I say, all right, I don't know what the cosine of 40 is and 80 and sine of 40 and 80 are, but does this match up with one of my formulas down here? So when I look at my formulas, I've got this minus sign. This one has a plus, so I've got to be dealing with this. So does this match up? So 40, 40, 80, 80, subtract cosine, cosine. Yep, that matches up perfectly. So I can rewrite this. That's equivalent to the cosine of 40 plus 80. So that's the same thing as the cosine of, let me make sure I've got my degrees, 120 degrees. Sweet, I know how to figure that one out. So 120 degrees puts me right here. We're 60 degrees away from pi. On this quadrant, cosine is negative. The cosine of 60 degrees is 1/2. And there we go. So you can kind of see how to do it the first way and then how to undo it the second way. All right, example 3. Find the value of cosine of pi over 2 minus theta. Okay, so we're going to be using this difference formula. We just don't have a value for our second angle. It's just going to be any angle. So this is going to be equal to the cosine of pi over 2 times the cosine of theta plus the sine of pi over 2 times the sine of theta. Now, cosine deals with the x, sine deals with the y. So at pi over 2, cosine of pi over 2 is going to be 0. And the sine of pi over 2 is going to be 1. So we end up getting sine of theta. And if you think about it, if this was an actual graph and we were shifting, those end up being equivalent, which is kind of cool. All right, next one. Is this familiar? True? Yes. Convince yourself with a specific angle. So that last example brings us to these cofunction identities, which are this right here. This is a lot of empty space. There was a proof here and I just figured